Hi guys, it's Mrs. DeLoss. We're looking at Unit 11, Skill 6. So today we're going to be talking about how we use the calculator to determine the probabilities from a normal distribution. So remember, your normal distribution curve looks like this, where your mean is smack dab in the middle, and then you go out by 1 standard deviation on each side, 2 standard deviations on each side, so on and so forth. So it's just a little bit of an extension from our 11.6 skill. So we've got Amy, who's a swimmer, and she specializes in the 50-meter backstroke. In a competition, her mean time for the event is 39.7 seconds, and the standard deviation of her times is 2.3 seconds. Assume that Amy's times are approximately normally distributed. And so if I were to just look at a picture with the mean and standard deviation on here, her mean would be 39.7, and then changing by 2.3 on either side puts us 1 standard deviation above at 42 exactly, and then 1 standard deviation below at 37.4. And then of course we could keep building outwards. But we're going to look at finding the probability or the likelihood that Amy's time is between 37 and 42 seconds. So we're going to draw the normal distribution curve. And we know that the mean of 39.7 would be in the middle, but 42 would be to the right of it, and the 37 that the problem referred to is somewhere to the left of it. It doesn't have to be super accurate, you just have to get them in the right placement according to the mean. Is it to the right of it or to the left of it? And if it says that we want to be between these numbers, then I'm going to shade in between them. That's going to help me figure out my lower bound and upper bound when we're talking about the probability. So in order to find the probability, there's a bunch of little pieces in the calculator that we're going to walk through, but we have to have what's called a lower bound and an upper bound. So I'm just going to write LB on the left-hand side equals lower bound, and UB equals upper bound. That way you can refer back to that language. So lower bound is literally the lowest we can go, and upper bound is the highest we can go. So if I have 37 and 42, the lowest we can go is 37, so that's my lower bound, that's 37. My upper bound must be the 42, because I want to stay in between those two things. I don't want to go beyond it in either direction. We also have to know the mean, and in our calculator it's going to look something like that. And so that is a Greek letter called mu, but it stands for the mean. It looks like an M, it is your mean. So we have 39.7 that we'll eventually type into the calculator. And then last but not least, we have this thing called sigma. That stands for your standard deviation. So this will be 2.3, and I'm going to also label that on the left-hand side. This will be our standard deviation. And again, the real word for this is sigma, and this one is mu, M-U. Okay, so we're going to go to the calculator, and the steps that we're going to take in the calculator are menu 6, 5, 2, or you can do menu 5, 5, 2. Either one will take you to the same spot, and I'll show you how that process works in the calculator. But what the calculator is going to spit out for us is something called the probability. So right away we will actually have our answer since we're just asked to find the probability, and it is to the nearest hundredth, so we will have to watch rounding 2 decimal places for the nearest hundredth. Okay, so we got the calculator here, and you can see I was doing some math earlier, but we have to get again to that point where we're typing in those 4 pieces of information. So the first step I'm going to choose to take is menu 6, because we're in the stats part of our unit, and then 5 because we're doing distributions, and then we want option 2, normal CDF. Now I do want to show you that if I were to go in the 552 direction with probability, because maybe your brain thinks about it like, hey, we're finding a probability, I'm going to go to probability. That is absolutely okay. 5, and then distributions, and then normal CDF. So 552 is perfectly acceptable. And again, you're going to see the lower bound, upper bound, the mu symbol, and the sigma symbol. Lower bound is that 37 we found. Upper bound is 42. Our mean was 39.7. And our standard deviation is 2.3. From here I click OK, And now it tells me the normal CDF with all 4 things that I typed in gives me this. This here is the probability, 0.721129 blah blah blah. But we're rounding to the nearest tenth, so that 2 looks at the first 1, and the 1 tells the 2 to stay right where it is. So this will be 0.72. So what this is telling us is that the probability that we would land in between those two values for her times for the backstroke is a 72% chance essentially, but the probability is 0.72. The next one says find the probability that her next race is between 42 and 45, and again to the nearest hundredth, so 2 decimal places. So it's a very similar situation, except this time, remember again, our mean is 39.7, 42 is above it, and 45 is even higher. So I again want to be in the space in between it. So our lower bound this time is actually the 42 because it's the lowest that we're allowed to go. And then our upper bound must be the 45. So lower bound 42, upper bound 45, mean 39.7, and sigma 2.3. So again, we're going to go to these steps, menu 652 or menu 552. Either one is perfectly okay. Alright, so again, menu, and then if I go 5 for probability, because we're asked to find a probability, 5 for distributions, because we're talking normal distribution, and we want to choose 2, 552, CDF. So lower bound this time is 42, upper bound was 45, mean is 39.7, standard deviation is 2.3. Click OK. And again, we're rounding to the second decimal place. This is our probability, so this would be 0.15 because the 4 looks at the 8. The 8 says, hey 4, you better bump up. Okay? So again, our probability, if you hadn't already written it down, is that 0.15. When we look at the next page, not the next page, I'm sorry, the next problem, maybe got you excited. We've got, let's see, the probability to the nearest hundredth that Amy's time in her next race is more than 45 seconds. So we've been drawing all the ones with the between, and then they give you 2 things. Let's draw some pictures off to the left-hand side for a minute that are going to be helpful when you see different scenarios. So our first option, like we've seen, is between, and you shade literally between. So this is when we're between 2 values. That's option number 1. Option number 2 is if we have a more than. So say we're somewhere over here and we need to be more than that value. Well, we would shade to the right because that's more than that number. So this is a more than. Another phrasing that you might see for this is at least. At least 45 seconds, more than 45 seconds. Those both mean the same thing. And then the last option we would have is if we had to be less than whatever that value is. So less than, we obviously shade to the left. And another way you could see this is at most. We are at most 45 seconds, or again, whatever the number happens to be. So when I look back at this example and I need to be more than 45, well, remember 45 is to the right of that mean of 39.7, 45 is here. I'm not shading in between them, so don't think that just because you draw that line in the middle for the mean that you're going to shade in between. It says more than 45 seconds, so I'm shading to the right. This does go on infinitely. It just gets infinitely small, 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 but it does go on forever. So keep that in mind when we come up with our lower bound and upper bound, because that does make a difference in our problem. So the lowest that we can go is here at 45. That's our lower bound. Our upper bound is somewhere way over here on the right-hand side. Technically, it's infinity, as we just said, but our calculator doesn't have an option to write infinity in there. So what we do is we make a really big number like 99999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999 nines. Okay, because that's large enough to make the probability work out for us. So we're going to set this up. We've got lower bound at 45, upper bound at 99999, mu for our mean at that 39.7, or 37, yeah, 39.7. I was thinking I got it backwards. Sigma is 2.3 for our standard deviation, and we are about to come up with the probability. All right, here we go to the calculator. Okay, so we're going menu, probability, because that's what we're asked to find. We're looking at distribution, so 5, 5 so far, and now 2 for normal CDF. So our lower bound is 45, upper bound is 999. Now you could put 8 million of them in here, but it's not necessary. Just 4 of them is fine. Your mean is at 39.7, and standard deviation is 2.3. So I click OK, and it does again say round to the nearest hundredth. So the second decimal place of a 1 looks to the right at a 0. 0 says 1, you better stay. So this will be 0.01. So what this is telling us with that 0.01 as our probability is that it's very unlikely for her race to take her more than 45 seconds. That means there's more likelihood that she gets done in less than 45 seconds. So this is very rare. Very unlikely. Based on a probability of 0.01. I don't know if you can hear Betsy, but she's freaking out, making noises. Okay, it says, what's the probability to the nearest hundredth that Amy's time would be at most 45 seconds? So I'm going to draw a picture. I have to interpret what at most means. Remember, 45 is to the right of our mean. At most means I can't be more than that. So this means less than, technically. So I'm going to shade to the left of that 45. That means the highest we can go is 45, based on my shading. The lowest we can go is way over here for our lower bound at negative infinity. Well, again, we can't type in negative infinity, so what we do is negative 99999. 999999999, right? So we want a really large number in the negatives. So negative 9999 will suffice. So again, lower bound is negative 99999. Upper bound is 45. Mean, 39.7. Standard deviation, 2.3. And here we have to find the probability. So I'm going right to my calculator. Alright, so menu 5, 5, 2. Now you'll notice that it says negative 9E99999. That is essentially the same thing as what we're saying. They just put more 9s on it. That's what that little E means. So you can actually keep that there if you prefer. You don't even have to change it. Or if you'd rather change it, feel free. And then 39.7, 2.3. Alright, so very likely that she's going to get less than 45 seconds, right? We said that before on the previous page. So it says round to the nearest hundredth again. This is going to be 0.9. That second 9 is telling an 8 to round up. 0.99. Alright, so the last problem here says, if Amy races 80 times, how many of her races will be finished in less than 36 seconds? So we're going to draw our curve. We still start at the same. We find out where 36 is in relationship to that mean of 39.7. And we want to be less than this, so I'm going to shade towards the left. And again, I remember that it does go on to a negative infinity. So my highest I can go is the upper bound at 36, and then we can go all the way to the left forever to negative infinity, but we don't use that. We use negative 99999. So lower bound is negative 99999. Upper bound is 36. Mean is 39.7. And standard deviation is 2.3 again. So nothing has changed so far. We just have to keep track of that 80 races in 2 steps from now. So we're going to write down the probability. Okay, so I've already got it all typed in, and I'm going to hit enter. And I'm actually not going to round this yet. I'm going to not write the whole thing, but I'm going to write 4 or 5 decimal places. Okay, so the probability that she finishes all of her races in under 36 seconds is 0.053814. Okay, I'm going to write that down. So now that I know the likelihood or the probability that she'll finish her race in under 36 seconds, if she races 80 times, I can just simply multiply by 80. So take your probability and multiply it by 80, and we end up finding that 4.3073 races is where she would finish in under 36 seconds. Well, we're not going to race 4.3 times, we're going to race about 4 times in under 36 seconds. That little tilde means about, if you want to use that. One more thing I want to mention is if it asks you for a percent. So say the problem says what's the percentage of the time instead of probability. So if asked for percent, take your probability and multiply it by 100. Because remember, probabilities are fractions that are always out of 100 essentially, because we're talking about percents that are out of 100. So if it asked you for a percent, what percent of the time does she race in less than 36 seconds? This one would look like 5.38%, right? Because multiplying by 100 moves it 2 spots to the right, your decimal. This particular problem did not ask for it, so if it doesn't ask for it, don't write it. Okay, keep that in mind. The last thing I'm going to ask that you do is write your summary with some important information that you learned today. So those things could be like the calculator steps. What do you have to hit in the calculator? It could be drawing your pictures with between and whatever shading to the right means and whatever shading to the left means in terms of the wording that you would see. If they ask you for a percent, what do you do? If they say how many for whatever the scenario is, what do you do? Right? So you've got to think about these things because you will have all different types of questions being thrown at you. Anyways, let us know if you have questions. Hope you have a good day.